give you till like the weekend to look over it, and then maybe Monday to ask questions. So we're looking at probably Tuesday or Wednesday. Okay, if you want to do a re-quiz for that. All right, as we look for it. All right. Let's take a look at these. Cosine 210. Caitlin, what you got?
Negative square root of 3 over 2.
Negative square root of 3 over 2. All right. If you guys disagree, I'm going to count on you to help me out here. Okay, on this one. Now, the cosine and the sine, those are usually can double check those, but some of the others you got to make sure you're on your toes. All right, sine of 3 pi over 4. How you doing that one, Max?
For sine of 3 pi over 4, I got square root of 2 over 2.
Square root of 2 over 2. Positive?
Yes, positive.
Yep, positive in quadrant 2. Sine's positive in quadrant 2. Tangent 300. What do you got for that one, Peyton?
Negative radical 3.
So you got negative radical 3. All right, how do you, what's your procedure for doing that?
I draw it out.
You draw it out? Okay. So 300. And let's see, that's going to be 90, 180, 270. So 300 will be right here, which means my reference angle is 60. And this is 30. And that means that's 1/2. Radical 3 over 2. So the point would be positive 1/2, negative square root of 3 over 2. You either need to be able to identify that it's going to be negative because of the quadrant, or you use the coordinates. I don't care how you figure that out, but you need to identify whether it's positive or negative. Tangent is y over x or opposite over adjacent. Either way, it's going to give you the same thing. So tangent of 300 is going to be negative square root of 3 over 2, which is y over 1/2, which is negative square root of 3 over 2 times 2 over 1. The 2's cancel. Definitely negative square root of 3. Okay, for that. Sine of 3 pi over 2. Sine is which coordinate, Maria? And what's it going to be at 3 pi over 2?
Negative 1.
-1. So I agree with that one. All right, Sarah, cosine is which coordinate?
X.
X. And what do you get for cosine of 240?
Negative 1/2.
Negative 1/2. Okay, agree there. Now we're going to throw some cosecants and secants and cotangents. So these are just cosines, sines, and tangents. All right, cosecant, how are we figuring that out, Eddie? What's the x, y, and what's that relationship?
It's going to be 1 over x. Or y, sorry.
1 over y?
Yeah.
All right, and what'd you get for your answer?
I got 2.
You got 2, because y would be 1/2 there. So, and I'm going to say probably the easiest thing is to draw it out. Gabby, how about secant of 330? What's the relationship? Cosecant's 1 over y. What's secant?
1 over x.
1 over x. Okay, and what'd you get for that one?
2 square root of 3 over 3.
2 square root of 3 over 3. Okay, I agree. Cotangent of 4 pi over 3. All right, how do I get the cotangent, Wendy?
I did. You show my answer.
No, how do we find? What's the ratio for cotangent?
Cotangent?
Yeah.
X over y.
All right, that's what I want. X over y. And then what'd you get for your answer?
Radical 3 over 3.
Radical 3 over 3. We agree? Okay. Secant of 150. Kylie, what do you got for that one?
Negative 2 square root of 3 over 3.
Negative 2 square root of 3 over 3. Agree? And last but not least, what do you got for cotangent 7 pi over 6? Gabby?
I have negative square root of 3.
Negative square root of 3. Is it negative?
No.
Oh, Sarah's saying no. It's in because it's in quadrant 3, so make sure it's positive. Positive square root of 3. We agree with square root of 3? Okay. All right, so we're going to keep hitting these. So, if you need to draw it out, draw it out. Make sure you know your triangles. Make sure you know where it's positive or where it's negative. All right, let's kind of work through those, the rest of those notes. I think everybody was here yesterday, correct? You got the notes? And this was on page 568. If you want to open up and look at that page, it goes through this problem. I think it's good to see. How far did we get on there?
Yes.
graph. 1, 2.
We just got the first point, right? Okay. When you are doing sine, and it says over a 1 period interval, okay, over a 1 period interval, what you want to think about is just this basic graph. This is your basic graph for sine. And that would be your 1 period interval. So, and start at 0, 0. Like, don't start at negative 2 pi. Start here. And so we want to figure out how the equation alters this graph. Which way it moves it. Does it stretch it? Does it reflect it? Everything that's happening to this graph. And I need these 1, 2, 3, 4, 5 key points. And we know their coordinates for normal sine. Okay? And it'll be pi 0. It'll be 3 pi over 2, negative 1, and it'll be 2 pi 0. So those are the coordinates, but we need to come up with the coordinates for the new graph. All right, so in this case here, given these key values, the 3 tells us the amplitude, right? So the amplitude, I know we already have that down, but I'm going to put it down anyway. So the amplitude equals the absolute value of 3, which is just 3. Tells you how high or low it goes from the midline. What else? What's to the right? Period? The period. So the period is determined by this constant right here. And it's 2 pi divided by that constant. So it is pi. That means it's going to make one cycle. Instead of going all the way to 2 pi, it's going to just take pi. Okay, to make one cycle. And then the phase shift. And that's going to move this right pi over 4. Right pi over 4. Okay, so now we got the 5 key points. Point 1, point 2, point 3, point 4, and then point 5. All right, normally, and I'm going to erase this here in a second. Normally, point 1 is 0, 0. Where has it been moved to? Or has it been moved? Eddie. It's been moved right pi over 4. Does anything else affect the y coordinate for this? Will anything affect it? No. So this is why point 1 is pi over 4, 0. Now, to get the other points, basically you're going to divide this 1, 2, 3, 4. Divide it into 4 equal pieces. So like if the period is 2 pi, you divide it in 4, and so you go every pi over 2 to get the next point. Well, how do we figure out how to get the next point for when we alter the period? Okay, we want to take the period. The period is now goes from 0 to pi, right? And we want to cut it into 4 equal, well, let's just think about it from 0 to pi. We want to cut it into 4 equal pieces. So how far do I have to go to get to the next point? Is that making any sense? What do you think? What would an answer? How far do we need to go, or what are you thinking on that one? You go pi. You basically take your period and divide it. Whatever your period is, you take that and divide it into 4 equal pieces. Well, our period was pi over 4. So that means now I go every pi over 4, and I keep adding that. And that's going to take me to my 1, 2, 3, 4 key points after the first one. All right, so when we're graphing, we're not at 0, we're at pi over 4. Here's what you got to do. You have to add to the x coordinate, you add the period divided by 4, which is pi over 4. Well, pi over 4 plus pi over 4 is what? 2 pi over 4. Now, I know that reduces, but just For this, I usually just leave it as 2 pi over 4, and then I'll reduce it later. What's the y coordinate going to be? Normally, for sine, on the second point is going to go up to 1. Is what's affected that in this graph? That 3's affected it. So now it then goes up to 1. It goes up to 3. So it'll be that point here. Now, again, add pi over 4. We always add pi over 4. So add pi over 4, and I get 3 pi over 4. And where does the next point go to? It'll be at 0. 3 pi over 4 is 0. Add pi over 4. I get 4 pi over 4, which, yes, it is pi. Negative 3. Add pi over 4. And then I get 5 pi over 4. 0. You got to graph those 5 points. Now, your grid is not labeled, okay? And I purposely leave it unlabeled so that you can change the scale as needed. So you don't have to use a scale of pi over 2. You can, but sometimes that's not the most convenient scale. Well, the easiest scale for this one would be pi over 4, but your graph stops a little short. You just have to extend it a little bit. That's fine. But that's what I'm going to do in this case. I'm going to make that pi over 4. I'm going to make this 2 pi over 4, but now I'm going to simplify it, make it pi over 2, 3 pi over 4, pi, and then you're going to have to extend yours to make it 5 pi over 4 in the guided notes. Well, we said it was started at 0, right? It went all the way up to 3, 0, negative 3, back to 0. So this is what I need to see. One cycle. One cycle.
In our coordinates, like whenever we have to write them like on like the test and stuff, should we simplify them or can we leave them how they are?
I'm okay if you leave them how they are. Okay, if you're like just adding pi over 4 and you leave it as 2 pi over 4, 3 pi over 4, and 4 pi, I'm fine with that. Okay, that's fine. But you're going to take your period divided by 4, and that tells you what to add. All right, now that's just one problem. It takes a couple to at least for this to start to sink in. All right, you got one below there. All right, graph y equals cosine of 2x plus pi over 3. Now, don't get ahead of me because there's something we got to fix on this one. And I want to do a couple things. All right, you got it written down. Let me do one thing here first. All right, what are we looking at for cosine? Okay, where are your key points? So this is pi over 2. If this is pi, if this is 3 pi over 2, and this is 2 pi, cosine starts at 1, goes to 0, goes to negative 1, goes to 0, and goes to 1. So it looks like this. Don't draw it as a V, okay, because it keeps going. But that's what our graph looks like. I need one cycle. I need these 5 key points, okay? We know the coordinates of these, but they're going to change based upon the graph. Now, if we got this number here, we got to fix something because if you looked at the top of the page, okay, with the way it's worded, it says y equals a times cosine of b. Is it x?
X plus C.
X plus c, then plus d. Okay, if you tell me the shift is pi over 3, that's wrong. What you got to do is we got to take this 2 and put it on the outside first. So if your 2 is on the inside, you got to factor it out. So it's going to look like y equals cosine of 2 times x plus, all right, that's going to change the pi over 3 to what, though? pi over 6. Basically, you're dividing that by 2, so it changes to pi over 6. So when you see that, and that happens a good bit, you've got to make sure you recognize that, pull that 2 out, and now we can figure out what's going on. All right, so our amplitude is just 1. Okay, because there's no constant in front of the cosine. The constant has to be in front of the cosine to change the amplitude. The period is going to be 2 pi divided by 2, which is pi. So it's going to, from the first point to the last point, it's going to be, this is going to be pi. And what about the phase shift? Phase shift. And that is going to be left pi over 6. And now you got 0.1, 0.2, 0.3, 0.4, 0.5. Normally, what's 0.1 for cosine? Let's see if we figured that out. What is normally, Eddie?
Negative pi over 6, 1.
No. What is normally 0.1?
It's going to be negative, 1. 0. I mean, 0, 1.
There we go. Now we got it. So normally 0.1 is 0, 1. And now, so what are you saying it is now?
Negative pi over 6.
Yes, that point has been shifted left pi over 6. Okay? So now I take that out, and the y value has not been changed. So it's negative pi over 6, 1. Okay. How do I figure out the next point? I gotta have the coordinates. Gabby, any ideas?
Add pi over 6.
Where'd you get pi over 6?
Or not pi over 6. Add oh wait, yeah, add pi over 6.
No, I'm going to disagree. Because here's what you got to do. Take your period. Now, what is our new period? Our new period goes from, it is a distance of, it doesn't start at 0, I know, but it ends at pi. It is a distance of pi, right? And we want to cut it into 1, 2, 3 equal parts. So you still have to move every pi over 4. Okay? So here's what we're going to do. And this is the rule. This is the rule. Take your period divided by 4, and that's what you always add. It just happens to be pi over 4 each time for these first two. But your period, if your period is not pi, you might get something different. So take your period divided by 4. And that is what you add to the x coordinate. So you add pi over 4 to that. Because from the first point to the last point has to be a distance of pi. Well, sometimes it's not very nice points, and that's okay. So really, you're taking negative pi over 6 plus pi over 4. And we got to figure out what that is. Well, I'm going to get a common denominator, 12. And that's going to be negative 2 pi over 12 plus 3 pi over 12. And if I did everything right, I get pi over 12. Okay. Nope, Caitlin says no.
Never mind. I forgot the negative.
Okay. Whew. I was hoping I was right. So I got pi over 12 for that one. Whoops, I went the wrong direction. So the point is now at pi over 12. What's the x coordinate or the y coordinate going to be? It's going to be 0. Oh, that should be a 12. 0. All right, add pi over 4. Add pi over 4. Now when I add that, so I'm taking pi over 12 plus pi over 4, which is pi over 12 plus 3 pi, and that's 4 pi over 12. I know that reduces, but like I said, doesn't bother me if you leave that, because then we're going to keep adding pi over 4, which is 3 pi over 12. So I got 4 pi over 12, which goes down to -1, add pi over 4. Okay, which is what? That's 3 pi over 12. So I get 7 pi over 12. That's back to 0. Add pi over 4 to the x coordinate. And that's another, what, 3 pi over 12, which is 10 pi over 12. 1. Well, that reduces to 5 pi over 6. So we're going from negative pi over 6 to 5 pi over 6. If you think about that, that's a distance of what? Distance of pi. It better be. Now, here's where it can be, you got to be careful. What are you going to label? You can pick a good scale and you can pick bad scales. And you can pick wrong scales. So there's difference. There's, a good scale and a bad scale just depends on, they're both correct, but maybe it's hard to put everything on there. And then there could be a wrong scale. All right, now I see this every now and then. If somebody, and don't write this down, so they'll do negative pi over 6, and then they'll do pi over 12. And then they'll say, I'll make this 4 pi over 12. And they just take every mark and they put their points. Is that correct? It's not correct. Let me just tell you that. What's wrong with it? Okay, if I'm saying this is negative pi over 6, that mark is, then what does that mark have to be? It's got to be pi over 6, right? They have to be equal. You just can't take the points and slap them down in the marks. All right? So if you let this be negative pi over 6, then this point here has to be pi over 6. Okay? And then this would be 2 pi over 6. So you got to be careful with how you write your scale. Now, one thing, here's my recommendation, a lot of times, it doesn't always work out, is find your smallest denominator. Okay, find your smallest denominator and see if that can work as a scale. So biggest denominator. So biggest denominator is 12. Okay, 12. Now, don't do anything yet. Can I go every 12? Here's the problem with going every 12. Negative pi over 12, negative 2 pi over 12, okay? And then this would be pi over 12, and then 2 pi over 12, 3 pi over 12. What would I have to go all the way over to? 10. So that would probably not be, it would be a correct scale, but not a great scale. Okay, because I got to go all the way over here to 10. So if that's not going to be really convenient, here's your next best option. Take your denominator and cut it in half. So take the 12 and cut it to what? 6. So cut it to 6, and this is what we're going to use for this one. And so it's going to be negative pi over 6. This has to be pi over 6. This is 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. And then I got to go all the way to 5 pi over 6 because that's 10 pi over 12. So I got to go an extra one. So I didn't purposely, I'll leave the x-axis blank so that you can put in the appropriate scale. All right, where do these points go? Negative pi over 6, 1. I'm going to make this 1 and this negative 1. I'm going to go up 2 just to make it a little bit easier to draw. All right. There's negative pi over 6, 1. Where's pi over 12, 0 at? That's a good question. Okay. Because you can't put it where pi over 6 is because that's not right. All right, so where would it be at, Caitlin?
Halfway in between 0 and pi over 6.
Good, because pi over 6, you can think about that as 2 pi over 12. Okay, so it's going to be halfway in between there. And so basically halfway in between is the pi over 12. So there's pi over 12, 2 pi over 12. And so pi over 12, 0 would be right there. And then, all right, where is 4 pi over 12? Well, that's 4. That is pi over 3. That reduces to pi over 3. Okay, where is 7 pi over 12? All right, well, think about this. Pi over, in terms of 12, that's 4 pi over 12. That's 6 pi over 12. What did I do wrong there? That should be 2 pi over 3, right? 2 pi over 3, which is 8 pi over 12. So the next one's going to be halfway in between these two, and then the last one will be 5 pi over 6. So depending on the scale you pick will depend upon like how, stretched out it is. Okay, but the period is still pi. We want to make this as, I guess, kind of easy to graph and easy to read as possible. You wouldn't want to go all the way like to 10 pi over 12. You could, but I wouldn't recommend it. Okay, for that. All right, so you really got to watch your scale. You really got to understand how to put your fractions in there. And if you notice, like between like the first and the middle point, it goes 1, 2, 3, 4. What did I do wrong there? It actually goes 1.5. Oh, it actually goes 3. 1, 2, 3. So you go 1.5 to here, 1.5 to there, 1.5, 1.5. All right. I want to do one last one, and I know I don't have room there, but this is kind of goes back up to the top. So you can, I don't know if you can slap it on or just pay attention or put it on your notes or whatever. What would this look like here over the interval negative 2 pi to 2 pi? So you would have to graph that whole thing from negative 2 pi to 2 pi, and I'm going to already have that out. So what does the plus pi over 2 do? Moves it which way? Moves it left. So you would take cosine, okay, normally is here, here. Okay, so here's your cosine. All right, so it's going to move it, what did we say, left? So that point here is going to be here. Okay, this will move over. Okay, this will move over. This will move over. What does the -1 do? Moves it down 1. Okay, so let me finish here. That'll move over. That'll move over. That'll move over. And then you got to think where that next point would be. So it goes there, and then it moves down 1. Okay, so everything moves down 1. So that's going to be here. This is going to be here. This is going to be here. There. 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 Here. Here. And here. So it's going to look like this. Okay, it still has an amplitude of 1, but you kind of think of the midline that cuts it in half, and then you go up, and then you go down 1. Okay, so that would be your final graph. Does that make sense? Hopefully. Okay, so it shifts to the left, moves down 1. Okay, now you got to read the directions. If it just says graph one cycle, all you have to do, one period interval, you just have to have those 5 points. If it asks you to graph it from negative 2 pi to 2 pi, you got to start it all the way over here. Yeah, you got to end it all the way over here. But these are going to be easier. They're going to be not as they're going to be nice shifts. They're not going to be like a pi over 6 shift. Okay, these are going to be something that's not as hard to do. All right, page 577. Okay, 54, 56, and 59 are like the ones where we did all the work for. Okay, those are like the ones we did all the work for. And you can plug them into your calculator to check when you're done and to figure things out. I would recommend you do it on graph paper, but not require it.